Hello students, welcome to another session of maths class. Today we are going to discuss about chapter 9, that is area of parallelogram and triangles. Students, you may recall that the part of a plane enclosed by a simple closed figure is called a planar region. Corresponding to that figure, the magnitude or measure of this planar region is called its area. This magnitude or measure is always expressed with the help of a number in some unit such as 5 centimeter square, 8 meter square, 3 hectares, etc. So, we can say that area of a figure is a number in some unit associated with the part of the plane enclosed by the figure. We are also familiar with the concept of congruent figures from earlier classes. Two figures are called congruent if they have the same shape and the same size. In other words, if two figures A and B are congruent, you can look at the figures A and B given in your book. So, it says that if two figures A and B are congruent, then using a tracing paper we can superpose one figure over the other such that it will cover the other completely. So, if two figures A and B are congruent, they must have equal areas. However, the converse of this statement is not true. In other words, two figures having equal areas need not to be congruent. So, let us discuss the example that is given in your book. We have rectangles ABCD and EFGH, and let us examine whether these two figures are congruent or not. Okay? So, let me draw the figures first, then we will go for the discussion. Okay? Students, आज we are discussing about the converse of the congruency. So, what we know that the figures or the surfaces which are same in area need not to be congruent. As given in your book, I have drawn the diagram. One is a rectangle and one is a square. The rectangle ABCD is of side 9 centimeter and 4 centimeter, and the square EFGH is of side 6 centimeter. As we know, the area of rectangle is length into breadth. Here length is equal to 9 centimeter and breadth is equal to 4 centimeter, and here side is equal to 6 centimeter. So, let us find the area. So, area is equal to length into breadth, that is 9 into 4, 36 centimeter square. Area of square is side into side, that is 6 into 6, 36 centimeter square. So, in both cases the area is 36 centimeter square, but you can clearly see that these two figures are not congruent, because we cannot put one figure over another, or we cannot superpose one figure over another. That is why these two are not congruent. These two are not congruent, though their area is exactly same. Okay, understood? So, now let us discuss the other given figure. Okay. So, students, I have drawn the diagram as it is given in your book. Okay. So, we have a planar region T and another planar region P and another planar region Q. The figure T is combination of figure P and figure Q. So, it is obvious that the figure T is made up of, or it is the sum of figure P and figure Q. That means the area of figure T is equal to area of figure P plus area of figure Q. Okay. So, we may denote the area of figure P as ARP and area of figure Q as ARQ. That means we can say that area T is equal to area P plus area Q. Okay. So, now we can say that area of a figure is a number associated with the part of the plane enclosed by the figure with the following two properties. Which is the first one? If A and B are two congruent figures, then area A is equal to area B. Okay? And if a planar region formed by a figure T is made up of two non-overlapping planar figures formed by figure P and Q, then area T is equal to area P plus area Q. Now, you are also aware of some formulae for finding the areas of different figures such as rectangle, square, parallelogram, triangle, etc. from your earlier classes. In this chapter, attempt shall be made to consolidate the knowledge about these formulae by studying some relationship between the areas of these geometric figures under the condition when they lie on the same base and between the same parallels. This study will also be useful in the understanding of some results on similarity of triangles. Okay? So, we will move forward and discuss these properties. Okay? Students, as given in your book, I have drawn 4 figures. In the first figure, you can clearly see that ABCD is a trapezium and EFCD is a parallelogram having same base DC. Now, the vertices AB of trapezium ABCD, which are opposite to the base DC, and the vertices EF of parallelogram EFCD, which are opposite to the base DC, they lie on a straight line, isn't it? The points A, B, E and F, we can say that they are collinear because they lie on a same straight line. That means as EF is parallel to CD, that means AF is parallel to CD, isn't it? Because they are collinear points, we can say that AF is parallel to DC. So, we say that trapezium ABCD and parallelogram EFCD are on the same base DC and between the same parallels AF and DC. They are between these two lines, aren't they? AF and DC. See, ABCD, AB is a part of AF, EF is also a part of AF. That means these two figures, the parallelogram and the trapezium, they lie between these two parallel lines AF and DC. Understood? Similarly, parallelogram PQRS and MNRS are on the same base SR and between the same parallels PN and SR. As vertices PQ of PQRS and vertices MN of MNRS lie on a line PN parallel to base SR. In the same way, triangles ABC and DBC, okay, lie on the same base BC and between the same parallels AD and BC. Now, parallelogram ABCD and triangle PCD of the fourth figure, they lie on the same base DC and between the parallel lines AP and DC. Okay. So, now I hope you have a concept of these figures from these diagrams. Okay? Now we can say that two figures are said to be on the same base and between the same parallels if they have a common base and the vertices opposite to the common base of each figure lie on a line parallel to the base. Students, now you can see the figures given in your book. We cannot say that triangle PQR and DQR of figure 9.6i lie between the same parallels L and QR. Similarly, we cannot say that parallelograms EFGH and MNGH of figure 9.62 lie between the same parallels EF and HG, and that parallelogram ABCD and EFCD of figure 9.63 lie between the same parallels AB and DC, even though they have a common base DC and lie between the parallels AD and BC. So, it should clearly be noted that out of the two parallels, one must be the line containing the common base. Note that triangle ABC and triangle DBE of figure 9.7i are not on the common base. Similarly, triangle ABC and parallelogram PQRS of figure 9.72 are also not on the same base. As I have explained these concepts over board, hope you have understood these concepts clearly. Now, let us discuss the exercise 9.1. Okay? So, students, the question number 1, it says which of the following figures lie on the same base and between the same parallels. In such a case, write the common base and the two parallels. Okay? So, let us discuss. There are 6 figures given in your book. So, let us go for figure 1. What we can observe that trapezium ABCD and triangle PCD have a common base CD, and these are lying between the same parallel lines AB and CD. So, this figure, that is figure 1, satisfies the requirement. Let us go for figure 2. It does not satisfy the requirement of the question. Why? It can be observed that parallelogram PQRS and trapezium MNRS have a common base RS. Fine. However, their vertices opposite to the common base PQ of parallelogram and MN of trapezium are not lying on the same line. It can be clearly observed from the given diagram that PQ of parallelogram and MN of trapezium are not lying on the same line. That is why this figure, that is figure number 2, does not satisfy the requirement of the question. So, students, let us observe figure 3. Does it satisfy the desired requirement? Yes. It can be observed that parallelogram PQRS and triangle TQR have a common base QR, and they are lying between the same parallel lines PS and QR. Okay? QR is the common base for parallelogram PQRS and triangle TQR. As PTS, the vertices, okay, vertices of parallelogram PQRS opposite to the base QR, those are PS, and vertex of triangle TQR opposite to base QR is T. The vertices P, T and S, they lie on a same line. That's why PS is parallel to QR, as we have discussed earlier. That means figure 3 satisfies the desired requirement of the question. Let us observe figure 4. It can be observed that parallelogram ABCD and triangle PQR are lying between same parallel lines AD and BC. AD is parallel to BC because ABCD is a parallelogram, and the base of triangle PQR, that is PQ, it also lies on the parallel line BC. But which is the base of parallelogram ABCD? ABCD and triangle PQR are lying between same parallel lines AD and BC. However, these do not have any common base. Base of triangle RPQ, that is PQ, and base of parallelogram ABCD are not same. So, though these two figures lie between same parallel lines, so these two figures, though they are lying between same parallel lines, they do not satisfy the desired requirement of the question. Okay. Let us discuss figure 5. It can be observed that parallelogram ABCD and parallelogram APQD have a common base AD, and these are lying between the same parallel lines AD and BQ. The vertices of parallelogram ABCD opposite to the base AD are BC, and the vertices of parallelogram APQD opposite to the base AD are PQ. All these vertices B, P, C and Q, they are collinear, that means they lie on the same line. That is why AD is parallel to BQ. So, figure 5 satisfies the desired requirement of the question. Now, let us observe figure 6. It can be observed that parallelogram PBCS and PQRS are lying on the same base PS, isn't it? However, these do not lie between the same parallel lines. That is why figure 6 also does not satisfy the desired requirement of the question. So, students, let us move ahead and discuss about parallelograms on the same base and between the same parallels. Now, let us try to find a relation, if any, between the areas of two parallelograms on the same base and between the same parallels. For this, let us perform an activity. As it is given in your book, that is activity 1, you can see on the screen there is a graph sheet and two parallelograms ABCD and PQCD are drawn on it, as it is shown in figure 9.9 of your book as well. These two parallelograms are on the same base DC and between the same parallels PB and DC. You may recall the method of finding the areas of these two parallelograms by counting the squares. In this method, the area is found by counting the number of complete squares enclosed by the figure, the number of squares having more than half their parts enclosed by the figure, and the number of squares having half their parts enclosed by the figure. The squares whose less than half parts are enclosed by the figure are ignored. Students, the areas that you find are approximate, and it will be approximately 15 centimeters square. Repeat this activity by drawing some more pairs of parallelograms on the graph sheet. You can observe. What do you observe? Are the areas of the two parallelograms different or equal? In fact, they are equal. So, this may lead you to conclude that parallelograms on the same base and between the same parallels are equal in area. However, remember that this is just a verification. So, students, let us perform activity 2 that is given in your book. Okay. So, it says draw a parallelogram ABCD on a thick sheet of paper or on a cardboard sheet. Now, I am going to perform this activity over here on this whiteboard. So let me draw the diagram first, then we will discuss about this activity. Okay, students, so I have drawn the diagram as it is given in your book. Okay, so the activity says that draw a parallelogram ABCD on a thick sheet of paper or on a cardboard sheet, but I have drawn it on the whiteboard, that is parallelogram ABCD. You might be thinking what these points are, A dash, E dash, D dash. We will cover in the next step. Fine. So the activity says cut a triangle A dash, D dash, E dash, that is A dash, D dash, E dash. Okay. Initially we have drawn the parallelogram ABCD. Okay. Now we have cut the triangle A dash, D dash, E dash congruent to triangle ADE. That means A dash, D dash, E dash is congruent to triangle ADE. Fine. So triangle A dash, D dash, E dash is congruent to triangle ADE. Fine. Okay. So we have to draw angle A dash, D dash, E dash in such a way that A dash, D dash, okay, coincides with BC. A dash and D dash, these 2 points should coincide. That means both the points are same with a different name, because we need to separate out this triangle from the parallelogram ABCD. So B is coinciding with A dash and C is coinciding with D dash. Fine. So that we can have a triangle A dash, D dash, E dash, and triangle A dash, D dash, E dash is congruent to triangle ADE. Fine. So note that there are 2 parallelograms A, B, C, D and E, E dash, C and D. Fine. On the same base DC. DC is the same base and we are having 2 parallelograms A, B, C, D and E, E dash, C, D with the same base DC. And between the same parallels A, E dash and DC. Isn't it? Parallelogram ABCD and parallelogram EEDACD having same base DC, they lie between 2 parallel lines AE dash and DC. Now, what can we say about their areas? Fine, let us find out. As triangle AD is congruent to triangle A dash, D dash and E dash, therefore that implies, okay, area of ADE, okay, is equal to area of A dash, D dash, E dash, because they are congruent. Okay, that means area ABCD. Now just think about area ABCD. A, B, C, D. Fine. Area ABCD, that means it is the sum of area ADE and area, what else? ADE, that means E, A dash, C, D, isn't it? Or we can say E, B, C, D. See, ADE plus EBCD, that is a quadrilateral. Okay, the sum of these two, the triangle and the quadrilateral, sum up to the area of parallelogram, because they are within the parallelogram ABCD. So their sum of the areas will be the sum of the parallelogram ABCD. Fine. Now we can write area A dash, D dash, E dash plus E, B, C, D. Why? Because area ADE is equal to area A dash, D dash, E dash. Now just concentrate on this portion. Area A dash D dash E dash plus area EBCD. Now see, EBCD and A dash D dash E dash, they sum up to parallelogram E dash C D. So it becomes area E dash C D, isn't it? Because now as it is congruent to this triangle ADE and this is the common part, EBCD is the common part in both the parallelograms, that's why the area which is equal to area of parallelogram ABCD. Okay. So the two parallelograms are equal in area. Fine. So students, we have discussed some concept about the chapter 9. Hope you have understood these concepts. Revise all the concepts and practice by making the diagrams. In our next class, we will discuss about some more concepts of parallelograms. Okay? Till then, keep smiling, keep practicing. Thank you.